Good afternoon, everyone. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. And I welcome you all to our new series, AI Sparks from Playground to Production. This bi weekly hands on series will show you how to build AI powered applications from scratch or add intelligence to current systems. Let's welcome our speakers, Vinayak and Shreyan, who will host this series. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speakers will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, let me bring in Vinayak and Shreyan into the stream. Thank you all and enjoy the session. Vinayak, your screen is up and the floor is all yours. Thank you.
Thanks, Rashmita. Welcome, Shreyan, to another episode. I think last episode we talked about what are the different features that are available in AI Toolkit, and today what we are going to do is we are going to explore a little bit more. We're going to explore um, different kinds of models. I think all of you already know about LLMs, and maybe that's why you're here. But many of you may not know about SLMs or have played along with SLMs. SLMs are like small language models. So we'll cover the small language models, reasoning models, and then also local models, and then we'll look at some use cases around that. So with that, let's maybe quickly into um, jump into the session. So, a little bit about the series. So, as I said, this is the second episode in the series. The first was about 2 weeks back, and we have a new episode every 2 weeks. And these are like all of the different topics that we cover. Me and Shriyan are the series editors for that. So, I'm a principal AI advocate at Microsoft, where I've worked with startups, enterprises, students, and actually help them train on AI, and also work with the product teams to make their products better. So make them hear the voice of customer really well. And one of those customers is actually Shriyan. Maybe Shriyan, you can quickly introduce yourself.
Yeah, hi everyone. I'm Shreyan Fernandez. Currently, I work as an executive software developer for KPMG India. And so I work with the open source platforms. I love to explore tech and all other emerging tech that's coming out. It's really exciting. So I started with generative AI around 1.5 years back. Besides my work, you can find me traveling around or getting lost in a good game. So yeah, that's about me.
Cool. Welcome, Shriyan. So, as I said, this is the second part of a series, and we're going to talk about SLMs, reasoning models, and local models, and we'll talk about some of the use cases. I hope you had a chance to scan and subscribe to the entire series as we go through it. So this is the agenda that we are going to cover. So first we'll have an introduction to small language models and how they differ from large language models. Then we'll introduce you to Phi-3, and actually just yesterday Phi-4 also got released. So we'll talk a little bit about that as well. Then we'll talk about reasoning models like DeepSeek and OpenAI O1 and O3, and then we'll talk about how do you download and test some of these on the AI toolkit. And finally, we will do a demo of port forwarding feature, which is quite useful to you, especially if you want to use the OpenAI API to through your apps to be actually able to test different things. So, what are small language models, right? So, small language models are language models that are smaller in size. They have lesser parameter count. Typically, I think between 1 to 8 billion. I think beyond that boundary, you would probably have medium kind of language models and large language models. They are extremely cost effective. They have deployment flexibility. They have ultra low latency when it comes to replying to specific questions, and they're easier to manage and fine tune. So because they are cost effective, they they put less burden on your on your budget, and they won't break the bank. In terms of compute, they can be deployed on decent sized CPU. You don't really need costly GPUs. Many of these can, as we shall see later, also can be deployed on the edge and air gap networks fairly easily. and uh, they can be deployed also on device on prem, so that makes it easier and that gives you a leg up. So especially if you're in a highly regulated environment, such as healthcare, finance, insurance, or you have data residency requirements, and something like SLMs would make make life easy, really easy for you. So again, these are some of the advantages. They can also run on your phones, as we shall see a little bit later. So what are the typical use cases? So the typical use cases for the smaller, less compute intensive models are they perform well at simple tasks. As I said, they work well in offline environments, whether it's on device, on prem, or wherever local inference may be needed. There are certain requirements where in application where the latency bounds are very specific, right? And LLMs may not be the best fit for that. So any latency bound scenarios where the response has to be within a certain threshold, I think SLMs can be tuned for that because they use lesser compute and have lower latency. Um, as we said, like cost constraint tasks, especially those with simpler tasks, resource constrained environments. Resource could be, in terms of memory, because the languages are not only use lesser compute, but they are lesser size, as you can see from the parameter count. And when you download these models, and we'll see a bit of these, in terms of the download size is much actually smaller, and they use much lesser memory compared to LLMs. And then again, these models can be easily trained for doing specific tasks, so they're very easy to fine tune as compared to LLMs. One drawback though of small language models is that it may not have the entire world knowledge, but that's not such a limitation, because you can go a long way by giving extra context via the prompt and prompt tuning, or you can use RAG, and we shall cover RAG in one of the next sessions in a couple of weeks. And they can be fine tuned for doing certain tasks better, right? So we'll look at one such family of models, and then I'll show you that there are other families of models that we can look at. So we'll look at the Phi series of small language models was introduced by Microsoft. They are groundbreaking when it comes to performance, size, and frictionless availability. So this is Phi 3.5 mini, has 3.8 billion parameters. Phi 3.5 vision has 4.8 billion parameters, and it is multimodal. That is, it can take image as a input and give you an output. And then there is slightly larger in terms of parameter count, which is Phi 3.5 mixture of experts model, which is 6.6 billion parameters, and that is also easily workable. That in So all of these are available on the Azure AI catalog. These are available on Hugging Face. These are also available on the ONNX runtime, NVIDIA, NIM, and Ulama. In addition, I talked about the Phi-4 group of models, which has just been released. The research model has been released. Phi-4 has been released some time back, and then the multimodal model and mini model has been launched on the Azure AI catalog just yesterday. And I'll point you to the links so that you can take a look at it as well. And going back to why these models are better, Phi 3 models are better, and now Phi 4 also has shares the same characteristics. Is It has the best quality to cost ratio. Especially, I feel having used Phi 4, I think compared to even Phi 3.5, I think Phi 4 is even much better, and we'll share the benchmarks a little bit while we do demos. They can run anywhere. They can run on CPUs and GPUs, on the cloud, on device. They can also run on your laptop, on NPUs. Some of the newer laptops have NPUs that can be used. They have blazing fast speed in terms of inference, and you can send in more context via prompts. So let's look at some of the benchmarks, just to quantify, when I say they are better performing, and they require less latency, how much better, right? So you can see in this chart the Phi 3.5 quality versus size. On the y-axis, we have the model quality, and that is the benchmark MMLU average, and you can see that Phi 3.5 actually is around 3.8 billion parameters, and it is actually quite high in the MMLU. It's close to like 68. And you can see the other models which are much larger. They also perform better, but the performance is much better than maybe something like maybe Mistral 7B, which has a larger parameter count, but in terms of in terms of uh, model quality is it's much lower. The mixture of experts again is a slightly larger model compared to the mini, but it performs much better when it comes to the MMLU average. So it is much better. Just a word of advice: if you are looking to fine tune a model, we have found that it is much easier and much more impactful to train the Phi 3.5 or the Phi 4 mini compared to the mixture of experts model. The mixture of expert model is slightly larger, and because of its internal architecture, it's a little bit harder to kind of fine tune to get the same level of performance, right? So, just something that you might want to keep in mind. As I said, Phi 3.5 can run on any device. Here it is kind of running on, on the phone as well. As you can see, we asked it a question and a recipe, and it's giving us a response. So quickly, I think I would say that the 5 series of model is worth looking at, especially if you are building fine-tuned models which fit a particular context, or if you just want the language. You don't need so much the world knowledge, but you need the language generation capabilities of an of a SLM or a language model. Then SLMs actually fit the bill very well. There are also other providers that provide SLMs. If you see Llama 3.2, there is 1 billion and 3 billion parameter model. Mistral has Ministral, which has a 3 billion and 8 billion parameter model. So these are also something that you can look at. Maybe what we can do is we can maybe show a demo now, if that's okay with you, Shriyan,
Yeah, we can.
of SLMs. Yeah.
Yeah, so let's now see a demo of Phi-3. So before moving on to the demo, maybe I'll show the model catalog, and then let's see what are the type of Phis that are available to us, right? So again, here we can see whatever just Vinayak spoke about, Phi-3 medium, Phi-3 mini, and then we have MOE as well. Along with that, we have seen about Phi-4. We just spoke a little about that, but that is also available to you, and it is served via GitHub, right? So now again here in this, in the last session, if you remember, we spoke about models that are also kind of running on your premises. So again, Phi-3 being a SLM that is capable of running on the local mod setup as well. So I've for now downloaded the Phi-3 Vision 128K. This is the model that I'll be using for all the demo today. And similarly, you can try all the other Phi family of models that are available to you. So now I'll go back to my playground and I will choose Phi-3 Mini, this one, right? And let's wait for it to load. So also now I see that there's a web option available here. So you can tick on that and you can have a web search enabled model as well, but it's only supporting for a couple of models and not all the models, right? So let me just ask in a question of what are pulses, right? So as you can see, it says generating and the token used. So yeah. So this is the answer that I'm getting right from the Phi-3 Mini SLM. So similarly, I can ask more questions. So let's say, what is theory of relativity? Okay. So we have an answer coming in. And similarly, we can also set the context here. So let's say if I have to ask this model to behave like a very helpful AI assistant. So let me, you are helpful AI assistant. So now I can again start afresh. Right. So similarly, you can set this context and play around with this model Phi 3 mini. Vinayak, do you want to add on anything to this?
I was just wondering if you have the vision model downloaded, maybe, and if you have an image, either you can show or I can show that maybe
Got it.
just add an image and ask it to describe it, so people can quickly see that. And again, this is by the way, this is running locally on Shreyan's machine, so it might take a little bit of time, because it typically will be running on the CPU.
Correct. So I'm just loading the model now, the Phi 3 vision.
Yeah, I think the model has loaded. So
All right. So as we can see, the moment I loaded the vision model here, it is kind of telling me that there's a paperclip icon that has activated, which is not there before. So this means that this vision model is multimodal in nature, which can also accept images as the input. Right. So again, now I will attach a file. So let's say I have a file lister. Sorry, I think let me just download one quickly.
do you want me to show that model if I have some images downloaded? You can just
Yeah.
use any image that you have downloaded, that and just ask it to describe it.
Sure. Yeah. So I have this fridge image here, right?
Okay.
So I will just upload this image and I'll ask, can you generate a, let's say, salad recipe with the ingredients in the image? Right. So as you can see, I have given a fridge which has a lot of things here. Can zoom it in quickly for you. It has a lot of content, some eggs, some I don't even know what is this. So there are a lot of things. It's not even identifiable to a human is what I'm trying to tell. But let's see how Phi 3 does a good job on this, right? So I can also see some tomatoes, some capsicums, and some bottles kept. So let's see how does it generate. So it'll take a while because it is running on my CPU right now. So once it is generated, we'll have a recipe that Gen AI
Yeah.
is telling us.
Yeah. So just to kind of give talk a little bit more detail about this question, right? So what we are asking it to do multiple things. We are given it an image, and we're asking giving it text, right? So first it has to identify what is it is there in the fridge. Then it has to use its world knowledge in terms of what are Shayna specifically asked for a salad, so it has to kind of take all of these into consideration, and then kind of combine these different ingredients um, in the same query, and then give you an answer. So and you'll see that it takes a little bit more time because that it is like it is a fairly complex query, because you're giving image as an input, so that goes through the that has to be kind of decoded, and things are to be identified, then you have to figure out how to combine them, and finally it will give you an answer. Shreyan, you can maybe show, like because it is running local, you can show that the task manager might
Yeah.
actually be consuming a bit of CPU. Yeah. And you can see that
So
here
as you
also
can
there should
see,
be some. Yeah, you can see that there should be something called an inference service agent that is actually using a lot of CPU. So it is actually running on the CPU, and it's taking a little bit of time for you to to generate.
right. So we can see this inference service agent here, the first one. It is actually consuming around 50% of my CPU right now to generate this answer to this particular question that I've asked. So let's just
And if
see.
you run it on a GPU, it is obviously it will be much faster. But in this case, we just wanted to show you that you don't need like a high-end GPU to be able to run the models. And the good thing about SLMs is something like Phi is like small enough that you can run with a constrained system like a laptop, because laptop typically may not have a lot of memory as well. So we'll maybe come back to this because it's taking a little bit of time. and maybe in the next demo we'll have it kind of ready. So should we move on to the next slide?
Sure.
Rashmita, can you just share my screen as well? Yeah, so before I go on, I actually just wanted to show you something that we just launched. This is the blog post about the 5 4 model, and as you can see that it has. Let me just zoom it a little bit. As you can see, there are two new models, 5.4 multimodal and 5.4 mini, which are like the successor to the models that we've shown. They should soon be available in the catalog. As I said, it just been launched yesterday, and you should be able to use this from the Azure catalog as well. So let me go back to the presentation, and then let's look at another category of models that we have, called reasoning models. So reasoning models are models that you probably have heard of before, like OpenAI O1 and O3 Mini, and this is from the OpenAI blog or the talks. So these are new language models. These are trained with reinforcement learning. They can perform complex reasoning, and reasoning models think before they answer. And we'll just see an example of what thinking means. They produce a long internal chain of thought before they respond to the user. So they will logically break the problem into smaller parts and then reason through each of those parts before they build up to the answer and give you the answer. So these models are actually very good in complex problem solving, coding, scientific reasoning, and also even multi-step planning for agentic workflows. We are not covering agentic workflows in this particular session, but one of the later sessions we will be covering that as well. So let's go and look at these features in a bit more depth. I have compared reasoning models with general purpose SLMs. So primary purpose is, as I said, like step-by-step problem solving and logical reasoning. General purpose SLMs are good at text generation and understanding. Problem solving approach, they break down problems into smaller subsets that show intermediate thinking. I'll show you an example of this in a bit, and you can show the output directly without any intermediate steps. So mostly LLMs do a pattern based next token prediction. And we'll see that in highly structured they have a highly structured output with a clear delineation between reasoning steps, whereas general purpose LLMs are flexible and conversational. There is a difference in the training data as well. The reasoning models are trained on step-by-step reasoning model reasoning logic, and then they also train on formal logic, whereas general purpose SLMs are focused on a diverse corpus of text which has different writing styles and purposes. um, Another thing, you can use chain of thought in LLMs, but they form the core of reasoning models. Going a little bit deeper in terms of computational efficiency, reasoning models require more computational power when it comes to inferencing relative to general purpose LLMs. And because of the step-by-step reasoning, it is easier to, in some sense, debug or at least understand, how a certain conclusion has been arrived at when it comes to reasoning model. Whereas general purpose SLMs are a little bit of a black box, which makes reasoning output harder to trace. Um, because they require more computation, the latency is also much higher. Uh, Whereas for general purpose SLMs, the latencies might be relatively lower depending on what the prompt is. In terms of examples, we have already talked about O1, O1 Mini, O3 Mini, and then DeepSeek R1. All of these are available on the GitHub marketplace of models, as well as these are available in the Azure AI catalog. And as I said, finally, the scientific reasoning, legal analysis, complex problem solving, these are the typical use cases that are there. With this, I can quickly show you example of this. Let me just go back to my browser. So this is an article that I have written. I'll give a link towards the end about how logical reasoning models are transforming, AI thinking. And I've explained all of this in quite detail. In fact, some of the slides have picked up from this, and then there are examples. So let me just go and pick an example from this blog post itself. So what I'm going to ask is, I am going to ask optimization problem. Let me just make this bigger. So this is one of the tasks that I am going to give it. I want to sell a certain number of items, say children's toys, in order to maximize my profit. And market research tells me that if I price it at $1.5, I will be able to sell 5,000 items. And for every 10 cents or lower, or every 10 cents, I lower the price. The number of items that can be sold become higher. So there are certain fixed costs like startup cost, which total 2,000, and the manufacturing cost per item, which is the marginal cost, is around 50 cents. So I have asking it find a price to set per item and the number of items that I need to sell in order to maximize my profit, and also determine the maximum profit that I can make. Right. So again, I'm asking it to one set the price and maximize my profit. So I've given it a multi-step pronged approach for this. So this will take a little bit of time to solve. So let me just quickly go to my instance. So I have already loaded. So I'm going to use DeepSeek R1, and the reason I'm choosing DeepSeek R1 is because you get good idea of its thinking process. So I've loaded the model, and I'm going to ask it this question. Again, this I'm using via GitHub, and you can see that there is a thought process. It is already. Can you see this? Maybe I can make it a little larger. So you can see that it's actually started the thinking phase. It is able to, it's first defining the number of variables. It's also giving each of them particular algebraic symbol, and slowly it is trying to build up that equation, right? What is the relationship between the variables? What is the relationship between the price and the profit? And obviously, it has, from its world knowledge, you'll see at some point it also we are not told it very specifically, but it understands that when I'm talking about profit, the way profit is calculated is you have a certain revenue, which is price multiplied by number of items. That is the revenue, and then finally, once you have the revenue, you subtract the cost, and then that's how you get the profit, right? So now here you can see that it's able to it's finding the relationship between different parameters. It's coming up with the different equations, and it's combining different terms. And then now it is figuring out, hey, I have come up with an equation that does seem okay, but I probably need to use calculus to be able to find what is the typical price of these, right? So it has now come up with a profit function now, right? So it has figured out the relationship and figured out the maximum profit. As you can see, it has come up with an answer, and now it's going to kind of check that answer, right? So it is not satisfied by just actually being able to come up with the variables, the relationship between variables, the equation. Uh, um, it's going to check it again. So it's checking the demand function again. And as you can see, the thought output can be actually quite verbose, and DeepSeek R1 is quite verbose. If you were to do with this with O1, for example, you would probably this step would not be as extensive. It would take some amount of time more. As you can see, it has not given us the final answer. We are still in the thinking phase. You can see that the latency is much higher, but the rigor in terms of solving it is much more deeper as compared to the LLMs that are used for that purpose. So it's again like re-verifying the math, in so it's trying multiple different one. Even though it has come up to an answer, it's checking that answer, it's checking its own thinking, making sure that it's logically inconsistent, and it has finally thought that okay, now all of these seems consistent, so it is able to kind of print out the answer for me, right? So now it is printing out the final answer for me. First is printing out the equation, and then it is coming with the particular equation. I think I think I've hit an error, but as you can see in this particular blog post, I can show you the result finally I get. It has again gone through this particular thought process, and it's able to come up with a demand function, a profit function. It is maximizing the profit, and then it's calculating the final profit, right? And you can see that it is optimal price is $1.25, and the number of items to sell is 7,500, and then the maximum profit is 63625, which we saw in the output a little bit earlier. If you see, yeah, as I said, I've highlighted this, so it has calculated and come up with the answer. Cool. With that, let me go back to the presentation. So I gave you an example of the reasoning models. Um, Now what we are going to do is, I think Shreyan is going to show you, how do you download and test on the AI toolkit, some of these models. We've seen a few examples. We've been able to download, test, and fine tune the models, and then evaluate and deploy them. We'll just go on to the demo here quickly. Especially maybe Shreyan, you can talk a little bit about Ulama models.
Sure. Yeah. Thanks, Vanak. So, Rashmita, can you share my screen? Yeah, thank you. So again, it has generated a recipe here. If you can see, it took a longer time, but it started typing it out. So again, that's how we can get more things on the playground. So now again, let's go back to our model catalog
Shreyan,
and let's see how to.
can you just show
Yeah,
the recipe once,
yeah, it
or
is
did
still
you?
generating. So I had to stop it in between. It's
Okay,
still
okay,
going on generating. But
okay,
yeah,
sure,
so I could just get all the ingredients that are needed that I can prepare my salad from. Right.
sure.
So here again, we'll come back to the ONNX models. This is what we will be looking into today. So let's say from this, I will type Microsoft as a publisher and a remote access. I can run with CPU. I can run NPU. Yeah. I've selected these three from the filters above. So all I can see now is we have Olama models here. Publisher is again Microsoft for Phi-4. I'll show one how do we utilize Quen from Olama in a while. And then we have ONNX models wherein we have this whole Phi family. So to download this, we would need a stable internet connection as the first kind of the, I would say, the prerequisites. So let's say I want to download this, just for example. So I can click on add, and we can see there's a loader that is running now. And here you can see it says that downloading inference model, and this bar has to complete for you to actually leverage that model, right? You can use that model. So now what I will do, I have already downloaded a model that is Phi-3 Vision and Phi-3 Mini. So I will use these two to see what can be, how can we inference with it, how do we utilize all the other aspects, and how do we test it out, right? So here, before that, I think I'll also show you the Olama, right? So I'll just cancel this one. I don't want it. And let me remove this. Yeah. So as we can see that this Quent 2.5 here is again provided to me via Olama, right? So what I will do is I'll have to download my Olama and I'll just show.
If you can just click on add, and it will show you the different variations. Can you just show that to the audience?
Right.
Um,
Sure.
if you just click on
So
add,
the moment I
yeah.
click on add, right, so here I can see what are the different types of models that are available to me. So let's say now I want to pull one of this like 3B. I have already downloaded 1.5B, so let me just pull in 3B now. So again, this is being pulled from my Olama server, and you can see the percentage bar is also shown here. That's at currently 2%. So once it completes, you'll have a Olama model already ready. But since I have already downloaded one, let me go ahead to the, yeah,
You
the
might
Quen
want to cancel
1.5B in
because
Playground.
it's going to hog your connection actually. Yeah.
Yeah.
Yeah. So I think many of these models actually are like in GBs, right? So just be conscious if you're
Correct.
on, some constrained network. So that's why I wanted, Shreyan to show you, what are the different variants that are available in the Ulama models as well. And hence I am asking you to cancel because
Right.
again, we are on a stream. So, that will actually hog the bandwidth as well.
Correct. Correct. So yeah, be very mindful of it because once I really tried it with mobile data, and my whole data was exhausted by the time I could not even download half the model. So be very conscious of these things, that you should have a very stable internet connection to utilize these, right? So again, I have loaded my Quen 2.5, which is hosted to me via Olama. And now let me ask a question that is here, right? Explain me the formula for Fourier transform using latex symbol. That was again shown to me in the playground as a, like a question that was already there. So I'm just using it as, and we can see that we have a very beautiful answer coming out from, again, I wouldn't say a LLM, but it's again in the category of SLM that we have it. Oh, it's
Yeah, so I
pretty
think this
well
is something
detailed,
that
right?
we saw. Yeah, we saw in DeepSeek as well, right? I think the way it renders. One of the good things about the AI toolkit, the latest version is I think it renders markup really well. So you can see that it has beautifully rendered here as well as earlier when I showed you the DeepSeek. So it just makes it easier to work with any kind of symbolic stuff as well. Especially kind of any kind of math related work as well. So whether
Right.
it's fractions, whether it's integration symbols, it actually renders it very nicely.
Yeah,
So this
it's
was a good
very
example. Yeah, Shreya.
correct. So we can see everything, right? In every single place that we see. I mean, even if I have to sit and type this out, it takes a longer time for me. But I think AI Toolkit does a very fantastic job here by actually giving it out properly. Like, e to the power of j omega, right? What is here? I would take at least 2-3 minutes to type it in, but we just saw that it was just rendered, and it was a beauty to watch while it was rendering. And even all these symbols, that was a good highlight as well from Vinayak, right? So this was about how do you use the models from Olama. But now let's see the model that we've downloaded. I think we just already saw a demo of this, but again, so I'll ask a demo with Phi-3 that I've downloaded, the Phi-3 vision model. Write a Python function to encode the input text in base64. Right, again, it is a little slower because again it is coming back to my CPU. And again, hardware is a big concern when we are using generative AI models. I think we spoke about this in the last session as well, that the more GPU based models you will be using, the better answers you'll be getting out of it. But here as well, it does a job, so it starts giving me the response here. Again, this streaming is completely dependent on the hardware that you own and not on the AI toolkit's capabilities.
Yeah. So our general advice is that if you have a good GPU on your desktop or laptop, I would suggest that rather than using the CPU model, use the GPU model. The reason we are actually both showing you CPU models is because we want to tell you that even if you don't have a high powered laptop but you still want to play around with models, it is still possible. So a lot of people, they feel that if they don't have like a very high powered GPU, they may not be able to use that model, but SLMs actually make that really easy. And another great feature of AI Toolkit, as you've seen, is there are remote models in using GitHub as well. So, for example, DeepSeek, I was not running locally; I was running it like remotely, right? Though there is an option, it's possible to run DeepSeek locally as well, via Ulama and other means. But it would be really slow because my computer is, my laptop especially is not like very high powered, and especially R1 model requires a lot of RAM to actually load it. That's the reason, if you have a choice, and if you go back, if later when Shane goes back to the model catalog, he can see that there are models that optimize for GPU and CPU, so you can choose based on your configuration. And you can do this like remotely as well, right? Like using the GitHub models, and you can see that there is such a difference in terms of the latency response that you get, because the number of tokens that can be throughput on a remote GPU system is much faster than even local CPU system. I think it has almost
Right.
generated like this function. Meanwhile,
Yeah.
as I was talking, yeah.
Yeah, it is almost done. It's just explaining it now. How does the function work? And I think it's a pretty good explanation. I would not definitely compare it with the LLM's output, but for a SLM that works on a CPU, I think this is doing an extraordinary job here, right? So uh, it's actually pretty helpful for me as well, that once it's downloaded, I need not connect to the internet. It's completely working within my premise. So yeah,
Yeah,
again,
and
it's
I
still
think Phi 4
generating.
is also Yeah, and 5.4 is also actually quite good, right? I showed you, like, you can 5.4 is available in the GitHub model catalog, and soon I think the multimodal for as well as a mini version of 5.4 will also be available, as it has just been launched. You can download and try them as well on your local machine, right? So yeah, so the state of the art is moving pretty fast. And I think I forgot to mention this earlier, but when it comes to language models, I think there was a race to have as many parameters as possible, but the CPU requirement or the GPU requirement was very high. But at some point, people realized that if you have better data, more curated data, and it is based on a paper that you can look up called "Textbooks Are All We Need," which is a riff on the famous transformer paper that attention is all you need. That kind of led to the birth of SLMs, and now I think with 1, 2, 3.3 and 3.5, and now with 4, you can see every version is actually much better, and as compact. So you can when it comes to the latency or the memory and or the GPU requirement, the bang for the buck that you get from SLMs is much higher.
Yeah, and I
Cool.
would also say it is very economical to run
Um,
a LLM.
I think there is one more demo, and yeah.
Sorry, Vinayak, your voice broke in between. But yeah, so what I was telling is kind of you have SLMs,
Yeah,
much pocket friendly language models. So it takes comparatively lesser amount of money to actually kind of run your SLMs on the premise. Yeah.
cool. So, Sriyan, do you want to maybe we can quickly go to the next demo?
Sure, sure. So all this while we kind of were playing on the playground itself. So we never. Now there might be a question, especially from the developer community, that how do I kind of leverage this in my code, right? So all this while we were looking at it from the playground perspective. We downloaded, we did all the multimodal capabilities. We used everything pretty much, but it was restricted to a playground. So now there might be a question, like initially when I was working with AI toolkit, right? So I had this first question that, fine, this is all great. Now how do I kind of use this in my own applications, right? How do I get it in the code? Or very simple example, how do I test it out on Postman, for example? Right, so that is also a capability that AI toolkit gives you, and that is given to us via this feature called as port forwarding, right? So port forwarding basically let's I would it's very technical, so I won't take much of time explaining the technical jargons behind port forwarding, but I would say that in very simple terms it lets you convert your um, whole LLM, the SLM, into a model as a server, and gives you a port connection, so from where you can interact with this SLM like you are talking to any random API, right? So I'll just show that now. How do we do that? So in this terminal section, I go to this ports option that is available to me, and I'll click on forwarded ports. So currently it says that there are no ports forwarded, but let me just create one. So I'll just set it to 5272. You can use any, but I usually use as a general practice, I kind of use 5272 as my port. So as we can see now, the port is forwarded. It says the visibility is private. You can of course change the parameters here, whatever you want to change. You can just right click on the port, and you can see what are the change. You can change the protocol from HTTPS to HTTP. Visibility you can change, copy the local address, and you can also stop this port forwarding, right? Or you can add multiple ports to this as well.
Yeah. So one more thing before we go on, I think we are almost at the end of our demo. So if you have any questions, actually put them in the chat. And after this demo, we will start taking questions. So yeah, please keep on, pasting any questions in the chat because this is the last demo that we have. Yeah, Shyam,
Right,
please continue.
right. So now it says the origin is user forwarded. That's basically I did it, so it's saying me that. So now let's test it with Postman, right? So all this while we did all these things via playground. So now I will just set a post here. As you can see, I've set it to post the request type, and HTTP, and this is my local host 127.0.1, and then the port that I forwarded it to, right? So it is 5272, and then the root, that is v1 chat and completion. So this is the root to which you'll have to request to from your model. So now I have to give the model name that I have, that is here Phi-3 mini. Again, this model name I have got it from here itself, from the AI toolkit, right? And the messages that I set, this is like the standard body that we kind of follow for all the LLM or SLM calls that we do in generative AI. So we set the role and we set the content. So it can be then again we set the role to the assistant, and then we set the content to what it is. So again, we'll talk about all these how do we do this, why do we do this in the upcoming sessions where we work more with RAG. And then we had this parameters, model parameters as well, that we could see in AI toolkit, right? So where we could set the temperature, top P, top K, max tokens, and stream. So again, stream is like, do you want the answer to be flowing out in real time to your application or not? So that I've set to false now. So with this, I do not have to give any authentication key or anything of that sort. So I'll just set it to send. So now it is sending the request to the model that I've hosted, right? So as you can see, okay, I'll just get this up. Yeah, my uh, content was high. So basically, I was just testing this SLM Phi-3. So it says, "Hello, how can I assist you today?" Right. So this is the same response that was coming out to me in this AI toolkit playground as well. So same message is coming out to me through the postman. So we are good that we now know how to get it out through port forwarding to postman. But the next question is, how do I develop an application? Right. So we have you covered with that as well. So let me share this code. Yeah, so here I have a basic app. So I'm not doing anything much here. Whatever I just got from the postman, I'm just kind of combining that with my coding. And so I've asked here that role user content, what is the capital of India, for example. So right, so let me just run this application. So again, it is sending a request to my, okay, there seems to be a problem. Yeah, so the problem here is that my LLM, the SLM that I hosted and the name I had given were completely different. So let me just quickly copy the name and let me post it here. And now I'll again start it. So as you can see, it says there is no model name it found in that. Okay, I think I missed.
So that shows it's a live demo and not like a canned demo, right? so
Yeah,
so you got it
exactly.
wrong. So this is also like an example of how you typically might get errors. So I think in a way it's pretty good.
Yeah. So as you can see now, when I executed the application, it says what is the capital of India, and it says the capital of India is New Delhi. Right. So again, the mistakes that I did previously was that I did not change the name of the model. So be very mindful of these things, because these, I think this is the error that many of you might face. So this is a good debugging trick for you, that be very mindful of the this particular thing. So now again, if you want to create a console level chatbot, like with basically how do you convert this into a chatbot at console level? So again, that also can be done here. So I'll run this application. It's the same code, pretty much the same code that I've written, except that I've changed the way the messages are being fed, right? Only this part is changed. So let me just run that. So it's asking me to enter the query than that embedded query that was there before. So let me ask the same question again. What is the capital of India? Although I know I'm very curious to again ask about it. Okay, again the same problem. I did not change the model name. So let me quickly do that. All right, so it's ready. So again, be very careful of this thing, that the model name should be matching with the model that is hosted. Right, so, or let me change what are pulses. Right, so you can see that pulses are these things. So it has come up with the answer. So now I have created a console application, right? So my console app is ready. Similarly, this is how you can pull it out from that particular AI toolkit window and then convert it as a server, and then start interacting with the models in this way. And you can use it in your own applications, be it your front end in a HTML, CSS, and JS, and then back end you want to use a Flask API, build a Flask API in Python, and then just expose it to your SLM that is again powered by AI toolkit. So this is how you kind of generate. So similarly, you can experiment more with this.
Cool. I think we have one last demo when it comes to the prompt builder, right? So
Yeah,
yeah. So let me just yeah. So yeah. Then please maybe you can talk about what prompt builder does a little bit. Yeah.
right. Right. So we just saw that in this Python application that I was just demoing to you. So I just wrote this prompt. You are a helpful AI assistant and provide structured answers, right? So again, I don't know how many of you think that this prompt is very good, but I would say this is a very basic level prompting. So what if I want to develop applications and I want to learn more about how to prompt an LLM in order to get the optimal response from it? So there are many tools available, but I think VS Code AI toolkit that we are using so far, it also has a tool something called as prompt builder. So what it lets you do is it lets you craft all these prompts on the fly, right? So I can just click on generate prompt and let's say create, or I'll just say a prompt for helpful AI assistant, right? So
For
let me
HR,
generate. Yeah, we can create it for HR as well. So I was trying to showcase it with this. How is this prompt? How can I enhance this prompt? So let's see, it's generating it for me. Right. So as we can see, the prompt that I had given there, you are just a helpful AI assistant, and the kind of
can
prompt
you
quality that
yeah, can you make it larger? The text
yeah,
larger. Just use Control plus plus. Yeah, I think as you can see, I think it has made it. It has made it actually quite detailed, right? It has given the steps, the additional details, and this is a good prompt. And actually, the lot of people think about RAG and fine tuning, but having better prompts themselves actually can enhance the output that you get from an LLM. Yeah.
yes,
Yes,
I
yeah. Please
I
do.
personally believe that than going to fine tuning, playing with prompts and RAG will give much better responses,
Absolutely.
and it is also less consuming the infrastructure that is there. So we can get better responses. So the prompt that I gave was just helpful AI assistant, but now the prompt that it is giving has a task description and additional details. It also has some examples here. So how should it kind of go ahead with the factual question? So for example, if I ask what is the capital of France, how should it respond to? So we have the prompt. Let's just test our prompt right away. So I can just, I think the window I have to just reduce a little more. Right. So I'll just type what is the capital of India. So let me run it. So again, now it is running against this prompt and it is saying that it's giving me all the set of thought process that it is going through, the reasoning capital and everything. And then finally you can see a conclusion of the capital of India is New Delhi, right? In the earlier sequence that I had just shown with the uh, Python aspect, these all aspects were missing. Again, why these were missing is because I wasn't prompting the LLM to give me these answers out. So do you know the fun part? Who designed my prompt? It was Phi-4 who designed the prompt, right? So similarly, I can ask other models to design it for me. But do you see the capability that Phi-4 has in while it is kind of helping me just in one task, that is designing the prompt? Imagine the power that it will show when I kind of use this in other techniques. For example, let's say RAG or any other technique
Yeah,
in
so it
Gen
is
AI.
it is very meta, right? Like even the prompt is getting generated by the this thing, and I think the reason why why we are using Phi-4 why the GitHub models is to show that they are actually much more capable. Because if you try the same thing for in the sense of time, you'll probably not demo it with say Phi-3 or Phi-3.5. You can see there is a difference in the quality of the prompt that it generates, and hence the answers that it generates as well. So with that, if there are not any more things to talk about, maybe we can take a bunch of questions. And Rashmita, if you can go back to my presentation, I want to share some links as well. So these are some of the links. I'll leave this slide on, so you can maybe take a screenshot or click on these links as well. And Rashmita, if you can just paste these links, let me just do that. To help you out. 1 second. I'll just paste this link in the chat as well. So if you want to be able to look at various resources, you can easily do that as well. Yeah. So Rashmita, I just pasted it in our window, so you can just paste it in the chat as well. And yeah, so I showed you the article about reasoning models. We have looked at multimodal labs. There's also a Discord channel. If you click on that link, you should be able to go to the Discord channel as well. That you can actually ask any questions, any follow-on questions that you have that we may not be able to cover. And we are also going to build our application in the next session. So you can look at all of these links, and it should give you a good handle about different aspects of AI toolkit, as well as learning different parts of building or different aspects of building AI applications. Yeah, if there are any questions, Rashmita, we can take questions. We're almost out of time.
I think there are few questions, but I'm not sure if those are answered. But then there is one from Aditi. I'll just get it up on the screen. Oh,
So how much memory does it take while running on mobile? Good question. Actually, the small language models, the memory is directly proportional. While we can't tell you the exact, because that will depend on how it is loaded into memory, what format, and that might be a little more hardware specific, and due to the parameter of the model, I can tell you that it's directly proportional to the number of parameters that you have, and the download size also, right? I think Shriyan, as for example, when he showed the download size, it's directly proportional to that. So typically it will be like a few GBs at least that you would require. Some models, if they are optimized, quantized to a lower fidelity, you might actually be able to do much less there in hundreds of MBs. Stan, do you want to add to that?
No, that is pretty much it. So again, if you're running it on, I would just say it's as a, you know, uh, point, like a key point that you can consider when you're using SLM. So the more smaller the model is, the faster it will give you the inferencing.
Absolutely.
So if you're having a low end device, then I would definitely prefer going with, the smallest model size that is available to you.
Cool.
okay, the next
Um,
question is, yeah.
Good question. I think we covered this in the last session. It's super easy to access the AI toolkit. If you go to the extensions, Shreyan, if you can, or maybe
Yeah.
I can just show that in a minute. Let me just go. So here I will show you. Just make it smaller. So here, if I go to the extensions and search for AI toolkit, so I clicked on the extensions tab and searching for AI toolkit. Uh, this is the extension that you can use. So it is free to use and download. And here I'm on the pre-release version, but you might want on the release version. But I can just use it, just download and start using AI toolkit. And as soon as you install it, you should get this icon on your sidebar as well, and that is what actually we have shown to you, right? Like, and then if you click on the model, you will get access to all of the the only thing I would add here is explore all of the features, and also go and see the videos that are there on this channel. So if you go to this, let me go back to the presentation. If you go to this link, if you go to this link, you should see the on demand. You should see, if you scan this link, you should be able to go to the on demand uh, version, which is towards the bottom part of the page, and you should be able to see the playlist. This video itself will be added to that playlist, and that's how you can use the AI toolkit very easily. So we have covered all of the features in the earlier video, so please go ahead and see that. I think we are at time and we'll stop here, but I'll leave this slide. So I would suggest that if you like this video or if you want to learn more about AI Toolkit, the full all of the features, we have covered that in the earlier session on 13th. It's available on demand. You can go and watch it, and you can look at all of the other features that we covered. There'll be more things that we'll be covering as we go deeper into this. And we look forward to seeing you again. If you can enter any feedback that you have about the session, the event, just scan this and enter the event code. It's a nice round number. It is the 25,000 event that we have for Microsoft Reactor. And let us know how we can improve the series. Is there any other topics that you want us to cover? We'll try to include that as well. And we hope to see you in the next session. Thank you so
Thank you.
much.
Thank you
Thank
so
you.
much, Shreyan. Thank you so much, Vinay, for hosting this session. And thank you all for joining us. Please do scan the QR code and share the feedback. And feel free to use the Learn module link. This will give you access to take your learning further. Thank you all once again and enjoy the rest of your day.
Bye.